Today we're going to talk a little bit about the AggLayer, where we're at. Really, it's been a long development road for us, and just want to be a little more transparent about where we're at in that journey. And so if you pay attention to our social handles last week, you may have seen a tweet come out. And for us, it's really interesting how we've perceived AggLayer internally versus how people externally have been seeing it. And what we didn't quite understand till more recently is that everyone inside of Polygon is really excited about AggLayer, and externally you have things like this, like Ag Summit, where you have a lot of people looking and there's a lot of visibility on it. We know we're making a ton of progress internally on AggLayer itself, but externally it may not be as visible, all the things that we're doing. And so this really came to light when we have a big release going out the door in the next couple of weeks, but most folks have no idea what that is. And so we wanted to kind of pull the curtains back from where we're doing and give everybody more visibility to be able to unpack what AggLayer is and our road to get there. And so introducing to everybody AggLayer version 0.2. Now, I'm not sure who came up with that name.
The same decision-making logic that chose this T-shirt created that version number. It's clearly a dev release, right? And honestly, the reason we have v0.2 here, like, this is not supposed to be like the big release that all the users and the end users come on and all of a sudden they're like egging or some shit. This is progress.
So exactly that. We didn't want to make a big splash with 0.2 because it very much is a development release. But what we did realize is it does unlock a lot of features that people are going to be interested in. And so we wanted to introduce it to the world so that people could start to look at AggLayer hopefully in a different light and start to appreciate all the technology and all the work that's going on behind the scenes. And so I'll go through some of the high-level features. And the first one is, in order to have AggLayer really be successful, it's got to be secure, right? And so behind the scenes, this version is what's introducing pessimistic proofs to the AggLayer. Pessimistic proofs allows chains to attach, EVM, non-EVM, but all with different security guarantees under the covers to be able to attach securely to the AggLayer without having to worry about another chain coming in and rugging your chain. So that was a huge feature for us, and one that we are putting together an integration guide so folks can start to attach their chains and understand how that process is going to work. Next, low-cost transactions. So moving from L2 to L2, there's no fees for fast exits. There's no liquidity pool fees. You can just move your money from one L2 to the other L2 without any issue. And lastly, one of the bigger ones is each chain underneath the covers that attaches to AggLayer, we don't have requirements that they use the same software. Each chain has its own sovereign stack. It can use it however it'd like. You can upgrade when you'd like. You can have your own native gas tokens and be able to move those throughout the AggLayer to other chains attached without having to add any kind of additional requirements. And so what's coming next? So as you've seen, this version still, moving assets from one chain to another chain still takes about an hour. So we're looking at how do we make this more user-friendly and bring the promise of AggLayer that we've talked about for low-cost, fast transactions. So you'll see in the next version, we're working very quickly towards fast interop and aggregation, which is going to enable both of those promises. But it wouldn't be possible without all the folks who are actually building with us. And so I think what's clear here is this isn't just a Polygon-driven initiative. The AggLayer really is done by a number of core contributors, ag chains who are already working with us to integrate with the AggLayer, and RAS providers who are building out these solutions, starting with CDKs and attaching them to the AggLayer. And so that was a high-level overview of what the AggLayer is enabling. For a more deeper dive, I'm going to pass it over to Paul.
Okay, so who here has talked to me at some point in the past. I know the immutable guys have, okay, all the Polygon people. I'm going to start where I normally start with this, which is a little bit of philosophy. It's a weird thing to talk to at a crypto conference, but we need to talk to a little bit of philosophy. So the words that Gabe used earlier, on the earlier side, was a sovereign chain. One of the core ideas behind the aggregation layer, the Agg layer, is that we want to build a system where chains can make their own security guarantees, applications can build applications in the way that makes sense for that application, but yet these systems can interoperate with each other well enough that we actually unlock the network effects between them, right? So we're not trying to like do the ecosystem game of capture absolutely everything. What we're trying to do is create an ecosystem that works together in order to capture this cross-chain, cross-application interoperability. The main way that we do this is this feature that we call the pessimistic proof. We are pessimistic. We are not optimistic. We have seen it. We have been through the hacks. We have actually lost money in these things. I have used all the bridges. They're terrible. I understand. Because of this, I am pessimistic. The idea behind the pessimistic proof, it's basically a proof of bridge state. So what we've been working on here at Polygon for the last number of years, and some of you just saw Jordy talk about how we can use zero-knowledge technology here, is that since we've been working on this, we realized that one thing that we could do that's something unique is that we can actually create a zero-knowledge proof. In this case, it's not zero knowledge. We're just using the proof aspect of it to show that each chain that's participating in the Agg layer has updated their bridge correctly. We don't necessarily care if they've updated their whole execution correctly. We just want to know that their bridge has been done correctly. Specifically, the thing that we want to know is that every single chain has not spent tokens that do not belong to that chain. Not about users, not about applications, but the assets that are on that chain. Can you move your thing? By having, there we go, Gabe. By having that, by creating this invariant that all chains can't overspend the number of assets that are on them, it allows us to actually take a little bit of a step back and look at what security means and to allow chains to decide upon their security model. We here at Polygon believe that ZK rollups, ZK validiums are actually, but we also understand that other ecosystems want to use other ways of doing this. For instance, L1s, they still can continue to use their existing consensus mechanisms, and we still want them to be able to interoperate. So the pessimistic proof, just the one idea that you need to keep in mind there is it's a proof that the bridge state was updated correctly on each chain that's participating with the Agg layer. We could talk in depth about how this works at some point, and we've got documentation that will come out in the next release. The second thing is that we're working toward here is proof aggregation. It's called the Agg layer, and people, the joke internally is like, when will the Agg layer egg? Nobody else found that funny, apparently. The joke with the Agg layer is like, it's actually multifaceted. So there's a couple of things. Aggregation doesn't just mean taking proofs and aggregating them, or like verifying multiple proofs within a proof, although that's like the technical meaning of the word. It also means aggregating liquidity. It also means aggregating demand. It also means aggregating user bases, right? But we're actually going to be providing the aggregation aspect of this into the proof as well. Currently, you can think of it like this. Each chain that's connected to the Agg layer right now does produce a series of proofs. When those are settled, they're all individually submitted to Ethereum, and the chain has to pay the cost of doing that submission. What we will be doing is basically bundling those all up into one. This brings down the cost of settling all the way to the L1 and allows us to do that faster. So that feature will be added in the next version as well. And then we also have this idea of the unified bridge. So the unified bridge, think about the Agg layer as two things. It's a settlement layer that is backed by Ethereum, and it is a unified bridge. The unified bridge is basically a structure where you can represent token movements across chains. The unified bridge here, it's very, very flexible, should be flexible with all of the kind of upcoming bridge standards that you're seeing. I don't know if anybody follows all the ERCs, but I feel like there's literally a standard every day that's like supported by 2 different teams. So standards, but we should be able to be flexible with most of those. The idea here with the unified bridge is that we can provide a unified experience where tokens can move from L2s to L2s without needing to first like be transferred in a multi-hop fashion. This is actually already fully live. The unified bridge is live. This bridge is what served as the basis for the currently live ZK EVM chain. How many chains do we have currently attached? 6? 8? 8-ish, yeah, okay. So that's on the unified bridge there. So these are the major components of what we're trying to bring together. And again, technical components. Next slide. In terms of UX, so earlier I said this sovereign chain concept. So, but the question is like, okay, we've got these chains, they can do stuff, right? Like, what are you actually trying to provide? There's a few major things here. The first is that because we want chains to be able to have like a really, really great UX, there's a couple of things there that you can only do in a shared sequencing environment. Specifically, the concept of atomic interoperability. This question is like, are there applications that are more interesting to build if you can have the requirement that an action must take place on both chains or no chain, right? This is the feature that you can add with shared sequencing. With the AggLayer, the way that we can do that is that chains, because they're sovereign, can opt into any shared sequencing layer they want to use, as long as they can share messages via the unified bridge, and they can provide a bridge proof that shows that they did everything properly. So this is the goal of this. In working with shared sequencing, we currently have a bunch of research with people. A lot of work with Espresso has gone into our shared sequencing strategy here. The second experience we want to provide, which actually gets better with shared sequencing, is fast interoperability. So one of the interesting things about bridges right now is often that there might be a path where something is fast, but it's hard to kind of provide fast across the board. You know, like I might be able to use a particular token and be able to go fast right now. So take something that uses a cross, for instance, right? They might have a whole lot of liquidity for USDC or for, you know, whatever, some other token. And so whenever I want to go spend my USDC on some side chain, it's very, very easy. But as soon as I want to move my like weird new token, there's no LP out there doing it. And so I can no longer get this fast property. What I end up doing is I ended up posting an order. Some market maker comes sooner or later and fills it, and it takes forever. Or in the case of a canonical bridge, that might take 7 days in an OP case or something like that, right? So what we want to provide with the AggLayer is a path toward all these chains to be able to interoperate with each other with that fast property. The way that we're going to do this is through basically pre-committing to the AggLayer that a particular token action has occurred. And because we get these ZK proofs that those state transitions were executed appropriately, every chain can be guaranteed that no other chain can lie to them. So this is a unique property that we're going to be able to do because of our usage of ZK proofs in this particular use case here. And then the last experience that we're really hoping to provide is one of a more unified token experience. Again, if you've looked at any of the bridges, you will know that there's a bunch of, quote, standards. We have OFTs, we have NTTs, we have X-chain tokens, we have all these things. In the AggLayer, because each chain is considered relatively sovereign, we actually don't care so much about the particular token implementation you use. And in fact, if you deploy the bridge to your chain, you can customize exactly how that works. But the interesting piece here is that any token that we can move across the AggLayer, we can actually create a unified token experience, which means that tokens that are minted directly to the AggLayer can move to all chains. That same token representation, regardless of the actual underlying contract that's being used, can be used on all of those chains. These three features we think like really brings together what users really need when they talk about interoperability, because mostly it allows the tech people to deal with the tech stuff and the tokens to get out of the way. That's what we're trying to provide. From a user experience perspective, we don't think that users really care about all these little details, and we need to provide a good technical basis for how those work. Did I even have another slide, Gabe? We will see. Oh, I do. Woo! So with these features, we're hoping to provide these benefits. And I'm going to say this on maybe a filmed thing, and I'm going to say the goal of these benefits is to try to make AggLayer real. When you look at v0.2, people look at that and they might say, what is this? It doesn't do everything that you've promised. Well, you can't do that all at once, right? So we're going to try to provide these full benefits. The first is that for tokens that are minted directly to AggLayer connected chains, they get this native token experience. This really means that the AggLayer can be your canonical bridge for your chain. We want to have safe cross-chain interactions. This is provided by the pessimistic proof, but a chain can provide a stronger guarantee than that if they want. What this allows you to do is to have two chains that have different security guarantees interoperate. This is really, really important. If you look at like what a game chain needs versus a DeFi chain needs versus like Ethereum, they have very different requirements of security, and we want to be able to support all of those. We also want to move just beyond tokens. The AggLayer currently mostly cares about kind of fungible tokens, but underneath that there is a shared messaging layer that is also verified via the pessimistic proof, via a slightly different guarantee. And because of that, we can start to build interesting interoperability functions on top of this layer. So for instance, we can use bridge and call, which is an existing feature where you can take a token, you can bridge it, and then you can immediately make a contract call with that. So you can start to actually build these like multi-hop actions. So using this, for instance, you could bridge an asset, you can immediately deposit into an LP pool, you could take the resulting token of that LP pool, you can move it over into another application, you could take a loan from that, you can move it further. So this is the kind of goal with that. And we also want to provide unified liquidity. Unified liquidity to us means that the majority of the liquidity on any of these ecosystems is directly accessible from any other chain. You don't need to take a bunch of hops, you don't need to take a bunch of risk, you don't need to use a bunch of third parties unless you want to. I just talked really fast, and we have 2 minutes and 52 seconds left. Did that make any sense?
So, yeah.
So the layer support like the L2 chains only, or is it support the L1 in order to like a Bitcoin, Solana, or something?
His question was, does this only support L2s? The answer is no. So specifically, there's an interesting case that you think about, like Polygon runs POS, right, which is it's a side chain. And in a lot of ways, it acts like an L1. Its fundamental security guarantee is provided by the validators that is then committed to Ethereum, and we need that to work with this as well. So yes, it does support L1s. The way that you could think about connecting to the AggLayer is that a chain needs to provide two pieces of information. One is they need to provide this pessimistic proof saying that I've updated my bridge properly and I haven't used more tokens than my chain has claimed. That's the first. And then the second is that the chain has reached finality. But finality is kind of like up to that chain. So that might be a proof of consensus, right? So I could have a consensus proof that a Tendermint chain has like actually gotten 2/3 plus one validator sign off. This could be a ZK execution proof plus a signature of a sequencer, right? Could be that. It could be some combination above plus a DA proof. So we want to allow chains to basically configure two things. One is an authentication method that says this is when my chain has reached finality, and a second one that says I can prove to you that my bridge hasn't been screwed with. With those two things, you can connect. There is a subtle difference here, though, which is that for an L1 chain, they're not going to be using the AggLayer as a canonical bridge because they don't really have a canonical bridge in that case. It would just be a bridge interaction, but they'd still be committing the same information to the AggLayer for interoperability purposes.
And just a slightly shorter answer, it's no, it doesn't. It supports more than just L2s, L1s, other ecosystems. We're looking to be able to attach basically anything to the AggLayer as long as they follow the mechanisms that we're designing there for the interface.
Okay, since you said it's a pessimistic rollup, that's what you said, right?
Oh, pessimistic proof?
Yeah, pessimistic
proof,
proof.
yeah.
Since this is a pessimistic, so how long does it take to finalize on the destination chains? Because if this is an optimistic, it's likely take fast to finalize on the destination chain. But if this is a person mistake, it take longer. For example, like L1 Ethereum, it takes like a 12-second blocks or maybe longer. And on another L2, it just take like 1 or 2 seconds to finalize. Then the problem is that you have to wait until the L1 curve finalizes the transaction and mine to the block until you release the token on the destination chain. That's my point. So how long does it take?
I'm going to punt this a little bit because you're actually going to need to read a document that I hope is public right now on our GitHub, but I will find out, and we should talk after. But the answer to that is like the ultimate goal is to have it be that you can move from chain to chain at the speed of finality of both chains. That's the idea. The max, because I need to know that the source chain has finalized and the destination is finalized for that to actually happen. That's the goal. There's a little bit of, there's some technical details in there that can make that difficult in certain cases, but I would like you to read our fast drop proposal if it's live or when it's live, which should be soon here.
Yeah, and that'll answer exactly the questions that you have there. We're over time.
Oh, we're over time, sorry.
Yeah, so,
we can talk after.
Any other questions real fast? Or less?
How does the bridge and call function work? So let's say I bridge from like chain 1 to chain 2, and then I want to call that function on chain 2. Who would the message.sender be on chain 2, like when it's calling a different contract?
Yeah, so currently that would be, it depends on how you implement that contract. So we actually have some interfaces in there for like basically bounce contracts so that you can have the claimer, the person that actually submits the message, route it through a bouncer so that you have like a particular entry point that is the message sender of the future transfers. Yeah.
And the bridge and call contracts are already public.
Those are already public.
Yeah, and so we can point you to that as soon as you're right after this.
I will be out there. Come talk to me.
All right, guys. Thank you.